All right, going live. Hello, everyone, and welcome to our webinar on simple problem solving brought to you by Kaizen Institute North America and our partners at Sioux College today. We'll be starting the webinar in just about 12 minutes from now. Looking forward to sharing this information with everybody, and thanks again for joining. Hi, everyone, and welcome to today's webinar, Simple Problem Solving in just about 10 minutes. Chuck Terry, the Director of Human Resource from Kaizen North America, will be presenting this webinar, and we look forward to having everyone on today's call. Hello, everyone. We're just about 5 minutes out from today's webinar on simple problem solving. Chuck Cherry, our Director of Human Resource at Kaizen Institute North America, is going to be presenting today, and we're proud to have our sponsors, Sioux College, sponsoring today's webinar. We'll be starting promptly at the top of the hour, so make sure that you have everything you need and you're comfortable and ready to learn about this really important step in the Kaizen process. So 5 minutes, we'll start our webinar. Hello, everyone, and welcome to today's webinar on simple problem solving, brought to you by the team at Kaizen Institute North America and with the sponsorship of our partners at Sioux College. We're so happy to have them on board today and excited for everyone to be here with us. My name is Jesse Martin, and I'm going to be the host today for Mr. Chuck Cherry. He's going to be leading us through our presentation. Chuck is an all-around good guy, and he is also the lead facilitator for our Yellow Belt program and the Director of Human Resources at Kaizen Institute North America. A wealth of knowledge and a happy face every single day, and he's going to be leading us through the webinar. And the agenda includes a question and answer period at the end of the presentation. If you have any questions at any time, I'll direct your attention to the chat box that is typically on the right-hand side of your screen. You can post your live event Q&A questions there. In the background, we can answer some of them. If they're a little more specific, we can keep them offline. If there are ones that are general, we'll post those out to the public feed, and we'll follow up with those questions at the end. So please feel free to utilize the question and answer box and send all your toughest questions to Chuck. It's hard to stump this guy. So with that, we're really proud to have everyone here with us today. Simple problem solving, and Chuck, I'll turn it over to you.
Thanks, Jesse, and welcome everybody wherever you might be in the world to our webinar on simple problem solving. I'm going to do my best right now to try to live up to that introduction that Jesse just gave for me. But this session that we're going to do today is a straight up sort of borrowing from one of the modules that we have in our Yellow Belt training session. We're going to spend some time this morning talking about simple problem solving and a way that we can formalize our problem solving process so that we come up with good solutions that prevent recurrence problems and that can set us up for good results in the future. So today, this presentation has been made possible by our friends over at Sault College. Sault College, located in Sault Ste. Marie, Ontario, is a publicly funded college in Ontario that's proud to sponsor this Kaizen event. We have worked with Sault College in the past. We've been happy to put on some of our belt programs there for some of their local businesses. And it's a partnership that we value immensely and look forward to continuing as we go along. Sault College is also working on e-learning platforms, and it's a process that we hope to join up with them at some point in time in the future. So thank you, Sault College. What we're going to do today is we're going to take the next 45 minutes or so. We're going to talk about using a fishbone diagram. You've heard, may have heard before, fishbone diagrams called by other names, Ishikawa's or cause and effect diagrams. But we're going to have a look at how those work and how we can use them in our problem solving. We'll then go along to talk about another very simple problem solving procedure called the 5 whys. And we'll have a look at how asking the question why 5 or more times can help us get down to root causes of the problems that we have out in the workplaces. We'll look at ways to verify those root causes, and finally, we'll talk about a communication tool that you can use to illustrate problem solving for things like team meetings and for also communicating throughout a workplace or organization about how certain problems were solved. We'll use the 3C tool to look at that communication process. At the end of the program today, we will have a question and answer period. But I also want to highlight that following the webinar today, you will get an email that'll contain 3 links. One of the links that it'll contain is to a survey. Anybody attending the seminar today and responding to that survey link will get a certificate of attendance for this webinar. But also in that email, there will be a link to go where you can download the PDF of all the slides that you see today. And you'll also be able to follow a link to our YouTube channel. You'll find us on Kaizen Institute North America's YouTube channel, and this webinar will be recorded and will be stored there sometime in the next 24 hours or so. But you'll also be able to go back and see the other recorded webinars that we've been holding in this free webinar series since the COVID-19 lockdowns have started. So you will have that email. You will be able to get all of those documents, and we will ask you to respond to a survey there as well. So simple problem solving. What we're doing really is talking about the importance of leadership in a lean journey, and some of that is involved in our 3 pillars that we have that formulate our Kaizen strategy. The first one of those pillars that we like to look at is daily Kaizen, because that's the area that we look to actually change Gemba behaviors and the culture in the workplace. And the question that we want to ask with that is, how do we develop people, and how do we sustain the improvements that we want to implement out in our workplaces? And that's all contained in our daily Kaizen strategy. And we'll have a little bit closer look at that right now. So daily Kaizen consists of 4 levels. The first being team organization, where we would organize the workplace into teams and hold meetings or daily huddles with them. We would then move along to level 2, where we have workplace organization. We implement things such as 5S programs, ensure that standards are happening, and process confirmation. And then we would move along to SDCA. And SDCA stands for Standardize, Do, Check, Act. And part of that is working to improve team member skills, which can include problem solving, and also leader standard work for training, work study, and problem solving. And that standard work involves the techniques that we're going to talk about today as we go through our problem solving process. And finally, daily Kaizen includes PDCA, which is the Plan, Do, Check, Act, or the Deming cycle, as you may know it. But we're going to focus on level 3. Problem solving being part of the standardization of a workplace and part of our SDCA. So what do we mean when we talk about problem solving? We're going to look at 3 different techniques today. What we're going to look at is brainstorming, which is very commonly used in problem solving process. And we quite often team up brainstorming with our fishbone diagram process that we'll look at in detail here as we go along. Following that, we would sort of hone in on what we think the root causes of problems are, and we would then invoke the 5 whys process, which is a way of funneling information to get down to sort of what's actually causing our problem. What is that root cause? And we'll look at how to drill down to that, and we'll look at methods to check and see if we are indeed on the root cause of a problem. So brainstorming, fishbone diagrams, 5 whys. That's what we'll look at as our main pillars for simple problem solving today. So first of all, brainstorming. Let's have a look at that. It's a great team engagement tool, and I'm sure that that everybody on the call has participated in or even facilitated some form of brainstorming in the past. And it's a simple process where you get a cross-functional group of people into a room, and you then start asking for ideas on what people would see as the possible causes of a problem that the organization is facing. It's a great way to engage your team. The whole idea of Kaizen or continuous improvement depends on idea generation from people in the Gemba, from workers out there where the value actually gets added into our processes. And brainstorming is a great way to engage those people, get the energy going and get them thinking about the problems that they face out in the workplace. And it also depends on freewheeling, the ability to be able to go and insert energy into a brainstorming process that'll get people's brains working. Get them thinking perhaps outside the box about what could be the possible causes of a problem, and getting out as many ideas as possible. But what's important when we talk about brainstorming is that we need to understand the exact issues or topics being considered, and we'll talk about that a little bit more as we go along here today. And we also need to keep our statements brief and clear. People give an idea and we put it down in a postie and put it up in a wall, or we put it on a fishbone diagram, and we'll have a look at that a little bit here as we go. But we need to keep those statements brief and clear so that we know what the idea is, but we don't use a lot of language up there because we want to keep the energy going, keep people thinking about possible causes. So we need to keep them brief and clear. We need to think about the possible causes based on data. We'll talk about a little bit about data collection before we get involved in problem solving as well, especially when we get down to our 3C tool. We'll have a look at that as well. But the important thing with brainstorming is you want to encourage participation by the entire group. Get as many ideas out there about possible causes of the problem as you can. And then hold back from criticizing any suggestion while the idea generation is going on. No idea is dumb. No idea doesn't matter. We capture all the ideas and get them onto the flip chart or onto the fishbone diagram that we're working with at the time. So sticking with the brainstorming idea. What we want to do, the steps that we want to go through, is to share our objectives and sort of validate with the group what it is that we're talking about. We want to define our problems. We then want to go through the idea generation. We want to share and spark ideas as much as possible with people, and then combine. If we have ideas that work well together, sometimes we can combine those ideas. When we finish the idea generation, we then go along to review and actually work with the ideas that we've generated. And we'll look at the fishbone diagrams as a way to organize that. Some of the things we want to do, we do want to examine the problem itself and talk about what the problem is. We want to ensure that we're allowing individuals to complete their thoughts, build on existing ideas, and allow people to think out of the box as well. Encourage those sort of out there ideas, because it's amazing what we can do when we start looking at some ideas and sort of drilling down into what possible value we could get out of some of these ideas as well. Quantity is what we're looking for. It's not quality in the brainstorming field that we're interested in. It's the quantity. Get as many ideas out there as possible before you start going through and prioritizing which are the ones that you want to work on. We also want to organize those ideas, and some of the things that we want to avoid. We want to avoid criticism, and including watching our sort of body language around that. Want to ensure that there's no rolling of the eyes or crossing of the arms when people are speaking. Make sure people feel welcome to participate in the process. We want to avoid making judgments, whether verbal or visual, as the ideas are being offered. And also, to ensure understanding, the facilitator quite often might want to be able to paraphrase or sort of go back to the person giving the idea and say, so what I'm hearing, is this your idea? And then paraphrase as well. We want to constrain without avoiding the outrageous, and we want to avoid situations where either the facilitator or any individual in the room tries to dominate the session. If one person dominates, that serves to squelch other people in the room. So we want to go through two things. We want to talk about fishbone diagrams, and then we want to talk about the 5 whys, as this contributes to our simple problem solving. Fishbone diagrams, you may have heard them before as described as Ishikawa diagrams, and cause and effect diagrams as well. So let's have a look a little bit closer at a fishbone diagram. It's quite simply called a fishbone diagram because it looks like fish bones. And it's a formalized process that we use to identify likely causes of a problem in an organization or in a process. We identify or group them into categories, and if the causes are not easily identified, we can always begin the team off with the 6 M's, and we'll look at those in a little bit later. So a fishbone diagram, quite simply, looks like fish bones. In the diagram itself, at the head of the fish, you'd put in your problem statement. And in the herring bones, or the bones coming off of the spine of the fish, you'd put the various categories where a problem can lay. And we'll have a look at this in a little more detail here as we go along. So the first step we want to go through in our problem solving is to articulate the problem statement, because that's what's going to go at the head of our fish. So this is our first step. The second step will be to identify root causes. The third step would be prioritization. And the last step would be to validate root causes. And what we want to do first is identify our problem statements. So what we do is we identify what our current state is, what is happening right now. And we then go along to talking about what's the desired state. And in between those two states lies our problem. So our problem is the gap between our current state, what we currently have right now, and our desired state. And when we define our problem, what we want to consider is the gap between that desired state and the current state. A good problem statement is specific, it's customer related, and it's measurable. So the first thing we want to come up with is our problem statement. And we want to include as much information in that problem statement as we can. For instance, here's an example, invoicing issues. That's not a problem statement, that's a category, because it's missing too much information to be a problem statement. For instance, how much? What kind of numbers are we talking about? What's the impact that it's having on us? So invoicing is not a good example of a problem statement. Here's a better example. 8% of invoices are rejected by the customer for incorrect pricing. That number is measurable. We know how much we're talking about. We're knowing what the problem is. It's being rejected by customers. And what the customers are experiencing is incorrect pricing. So this is a good example of a problem statement. So this is where we need to start in our problem solving process, is with that problem statement. We would then go along to identify the root causes. And this is where our fishbone diagram would come into effect. And using in a physical process, so this might be out in an operation, it might be a process operation, it could be a manufacturing operation, but something physical. You could start with your 6 M's. And in the problem statement, you would fill out at the head of your fish over here, and then you'd go along to filling out your 6 M's. Starting with manpower, methods, machines, materials, measurement, and Mother Nature. And we'll have a look at what could be included in each of those. But this is just an idea to get you started. So you'd get your team together, you'd define your problem statement, and you'd then go along and say, well, quite often problems are contained in one of these 6 M's, and you could label the herring bones on your fish with those 6 M's, just as an idea to get started. You don't have to use 6 M's. These could be different categories and you could pick and choose your own. But this is a good way to get started. If you're new with the process and you haven't done this a lot, you can use the 6 M's. So the 6 M's being manpower. When we talk about manpower, we're talking about anybody that may be involved in the process. So it could be the operators, it could be vendors, it could be even customers, it could be people at any step along the process who's involved, who are contributing to the problem. So if you went through your brainstorming and you talked about people, you could capture those ideas under manpower and put sticky notes saying, okay, operators on the night shift don't follow the same standards as the operators on the day shift. You could put that into manpower, capture that idea on the sticky and put it under the manpower fishbowl. Another M, methods. This could be how the process is performed. It could be anything around policies or procedures. It could be regulations or laws. Any of these things would fall under the methods herringbone. Machines would be any of those physical processes that are required to accomplish the job. It could be process machinery. It could be tools that are being used to complete the process. Any of these types of things could be under machines. Materials, which could be raw materials, it could be parts, papers, anything that's added into the process could be under materials. Measurements being some of the devices that we use to gauge the process, could be any kind of data that's used to evaluate quality. Any of these things could be under measurements. And then finally, Mother Nature. We need to ensure that we're not leaving out things like the environment from our problem-solving process. Could be time, temperature, maybe things are different in the summer than they are in the winter time. Quite often up here in Canada, that's the case. In the winter, you have a completely different sort of environment to deal with than you do in the summertime. So don't leave out Mother Nature as well. So any of these 6 M's could be where your problem lies. So here's an example, silly little sort of example of the fishbone diagram in action. What we have here, our problem statement is an employee laptop runs out of power. Now you could say that that's a poor problem statement because, well, it runs out of power. Does it run out of power after 6 hours of use? Or does it run out of power after 6 minutes of use? You could add a lot more information and come up with a much better problem statement if you collected more data around what the employee is actually experiencing with the power. And then we put in our, as you see there, what we have there is 4 M's, a P and an E. They've changed up some of the 6 M's on this fishbone diagram example a little bit. But they got the cross-functional team together. And in the cross-functional team, there might be the operator of the laptop that's run out of power. You might have somebody from the IT department. You might have other people who use similar laptops in their work. You'd want to gather together a few people, 4 or 5 people into the room to try to generate ideas about why this laptop has run out of power. And the people would then brainstorm and come up with the ideas, and they would be captured under the appropriate branch of the fishbone diagram. For instance, people said, well, maybe the employee has poor training. Well, that'd be captured under the people branch as poor training. And offshoots of that one might be people don't care or have no training budget. So these are the types of things that might happen under people. In the 6M method, that'd be called manpower. Then under methods, perhaps the employee doesn't charge the laptop nightly. Under machines, perhaps the battery is old. Under materials, they said maybe there's poor documentation. Maybe the documentation doesn't cover how long to charge the laptop for, etc. But there would be a brainstorming session with the fishbone diagram, either on a flip chart or a whiteboard or something. And you would capture these ideas under the appropriate branches of the fishbone diagram. And then you have the 6 Ps. If you're dealing with an office process, quite often people like to use a different set of criteria than for a mechanical process for their fishbone diagrams. And here you see the 6 Ps. normally used in some type of office or transactional process. The 6 P's being priorities, process, people, program, products, policy, that can be used similar to the 6 M's that we see in a process. And those 6 P's programs could be referred to insufficient sort of programs for the process, or they're unclear, or bad feedback systems. Other things that could be talked about are under priorities. We could have, is it low priority, high priority, or not enough attention is given to something contributing to a problem. People, we see things like training or absenteeism, cultural differences between people as all possibly contributing to a problem. Under products, could be wrong specs, poor instructions. Under process, lack of standard work, lack of best practices, all of these types of things could be under process. Or under policy, for instance, it's country dependent, or it depends on regulations in the particular environment that you're working in, or could be subject to translation from another language. All of these things could be under process for the 6 P's in a transactional environment. So you'd capture your ideas, and then you'd want to go along to prioritizing what the group thinks the most likely areas for the problem to lie is. And you'd go along and you would then prioritize those areas. And the prioritization might look like this. In this fishbone diagram, we see the problem statement being delayed collection time for accounts receivable. And the cross-functional group brainstormed, 20 or so ideas about what could be contributing to that delayed collection time. And once all of the ideas were generated around that, they went back and prioritized, and they circled several areas as areas that they want to concentrate on trying to focus on to see if that's where the root cause of the problem lies. So it could be lack of follow-up, multiple overlapping activities. It could be a lack of accountability, or a process breakdown, or lack of protocol. Any of these areas could be the root cause of delayed collection time, or it could be a combination of those causes that are contributing to the problem in the organization. So you'd go through, you would identify the branches on your fishbone diagram, you'd brainstorm possible causes of problems, and you would then, at the end of it all, prioritize areas to do more work around in order to find what the root cause of the problem is. And here's an example of a fishbone diagram process here. And yet, as you can see, it can go along and be quite detailed. In this example, you'll see the sticky notes. It's always a great idea to use sticky notes when you're working your fishbone diagrams. It can help you avoid a lot of erasing, and it's very simple to move a sticky note around. Or if you want to refine something, it's easy to add information if you want. But as you can see here, the fishbone or Ishikawa process can get quite detailed. And there's a lot of information sometimes to go through. So you would then go through and prioritize those issues. Here's another example here. And what we see here is we see an example of payment of invoices. That's not a problem. Payment of invoices, you can argue, is a good thing. You like to get paid for invoices. So what I would do if I was facilitating this process here is the first thing I'd want to do is get more data around what do we mean when we say payment of invoices? Are they not? Are we having 30% of our invoices being paid in 61 days? Or what is the data? How do we actually describe what the problem is that we're trying to solve? And here you see the headings on the branches of the fishbone diagrams have been changed a little bit to suit the group that's working on the problem solving. You can see branches called supplier loyalty or unrealistic employer expectations. But what the important part of this is that the group has brainstormed, 10 or so ideas about what could be contributing to the payment of late payment of invoices that this fishbone diagram is trying to get to. So we'd start there, we'd prioritize, we'd narrow down specific ideas to look at, and we then might go along to the 5 whys process to try to funnel down to the root cause of those problems. So we'll switch now to look at 5 whys. 5 whys are quite often used in parallel with fishbone diagrams, although with simple processes, simple problems, you might use the 5 whys by itself. So the 5 whys is quite simply a process where you ask the question why enough times to get down to the root cause for why a problem exists. And what it tends to talk about is why things happen. It goes along to until you get down to the place where if you block the cause, you eliminate the effect that it has. So we repeatedly ask the question why and try to get down to the root cause. What we tend to do quite often when we face problems is treat the symptoms of problems. So we may have a machine that's set up badly, and this setup might be causing some type of a defect in the product that we're making. If we try to fix that defect, what we're doing is treating the symptom. What we want to do is get down to the root cause and talk about what's causing this defect in the first place and eliminate that problem so that we prevent recurrence and we become more efficient and we improve our processes. So there's a great focus on getting down to root cause. The root cause is identified as the reason or source of a defect or problem. And what we want to do ultimately is prevent the recurrence. So what we do is we quite simply ask the question why enough times to get down to the root cause. So what we want to do is we want to funnel. We want to start by asking the problem. Start asking why around the problem statement. And what we'll do is we'll then ask why around the answers to those questions until we get to the root cause. Ideally, what we do is we ask the question why, and we come up with a single statement. And then we ask about, well, why does that happen to that answer? And we keep on asking the question why until we get down to what we feel is the root cause. And the number of whys that we will use, we call it the 5 why process, but it could be fewer and it could be more, depending on how complex the problem is that we're trying to solve with it. And now I'm going to put on my other hat, because I'm also an HR director here. And part of the communication processes that I teach is telling people to be careful with the question why during conversations. And you might think, well, why do I need to do that? And it's because the question why for people sort of invokes an automatic defensiveness. As soon as you ask somebody why, they feel like their judgment is being questioned, like there's some other sort of reaction that they should have taken rather than the one that they chose, and you're trying to figure out where their reasoning is flawed. And so what I like to do in that instance is whenever I'm going to use the 5 why process, I like to explain to people, I'm going to go through this 5 why process, and what that means is I'm going to ask the question why a lot to try to get down to why the problem actually exists that we're dealing with. And if you explain what you're doing to people before you launch into the 5 why process, you'll find that they're thinking about the question that you're asking them about thinking, rather than thinking about why are you asking me that question? What it does when you explain why you use the 5 whys is it builds trust between you and the person that you're using the question with. So, why? What are some of the benefits of the 5 whys process? Well, first of all, it's easy to learn and it's easy to use. It's very simple. It is a systematic approach to problem solving that people can understand and can use really without a lot of preparation. It also challenges assumptions. Asking that question why continually also challenges assumptions that we may have about a process. Why do we do it this way? And often it is, well, it's the way we've always done it. Well, let's challenge it. Why is it all the way we've always done it? Let's challenge that and get down to root causes. It's also, when used in an effective manner, is non-blaming and non-judgmental. It isn't about people, it's about processes. And focusing on that helps us to build trust in the process as well. And it can also be used very well in a team approach. So it has all of these benefits. But what about some of the weaknesses of the 5 whys process? Well, there's a tendency to stop short of the true root cause. And there's a great video that illustrates this. If you go to YouTube, and you can do a search into the 5 whys process and look at the Jefferson Memorial. There's a great video there that illustrates stopping short of the true root cause. We tend to go off and solve the first why. Often that's our natural intake. Oh, that's got to be the problem. Let's solve that, and we cut the process short. What we need to do is we need to keep asking the question until we get down to where we feel we have the root cause, and we'll look at that process here in a little bit, in a little deeper way. The other problem is we don't know what we don't know. It's limited to the current knowledge of the people that are going through the process. So what we need to do quite often is we need to get out into the Gemba. We need to get out into the workplace. We need to gather data, and we need to get as much information as is required to get down to the root cause. Because if you're only asking one person, you're limited to the knowledge of what that one person has. And sometimes results are not always repeatable. And you might say, well, why is that? And that, again, depends on who you're talking to. Everybody has different experiences. Everybody has a different sort of history behind them, and they experience things in different ways from one another. So you can say that the process isn't repeatable depending on who you're talking to. Because anytime you're talking to an individual, you're dealing with their data pool. They're dealing with their experience, and you're dealing with things that they've gone through in the past. And that could be different even if you talk to the next person along the line. They've got different experiences, and it may not be repeatable. So those are some of the weaknesses of the 5 whys process as well. So let's go through an example of the 5 whys process. And here's one where bolts are loose on a piece of machinery. So you would you'd go through with your problem statement. Your problem statement might be bolts were loose on this particular flange, and as a result, we had a leakage of product. So you would start out with the problem and say, why were the bolts loose? You might have a team of individuals. You might even have, or may only have one person that you're going through the process with, and you'd ask the question why. And that person would say, well, the maintenance team member did not properly secure the bolts. You might then ask the question why again. Why didn't they properly secure the bolts? Well, the team member didn't follow the standard work. Well, why didn't the team members follow the standard work? Well, the team member had not been trained on standard work. The team member was not aware that there was a standard process for it. And you then wouldn't stop and say, well, let's go train everybody. You would say, well, why wasn't the person trained on the standard work? And the answer to that might be, well, the maintenance supervisor forgot to train. And again, this would be the place where a lot of people would say, oh, well, the maintenance supervisor is lazy. The maintenance supervisor doesn't know what his job is. The maintenance supervisor doesn't care. All of these types of things might pop to mind and people would run off and solve those problems. But we still haven't got to the root cause. Why did the maintenance supervisor forget to train? Well, there was no standard training checklist to follow. The supervisor had a lot of things to train this individual on, and there's no checklist for it, and somehow or another it got left off. Now we're down to the root cause of the problem. The maintenance supervisor didn't have a standard checklist to follow. So that's the problem that we need to solve, because what we want to be all the time, it'd be easy to blame the supervisor on this thing. But what we want to be is hard on the process and easy on the people. We have a tendency, particularly here in North America, to want to find somebody to blame for something. And in a lot of traditional organizations, we spend a lot of time getting invested in whose fault is it. What we want to do in a Kaizen lean environment is find out what lacks in the process that allows this problem to exist. And we want to fix that process. We want to be hard on the process. We want to be easy on the people, because that then allows us to keep those people engaged. They're not as worried about deflecting or finding excuses. We want to get people focused on solving the problems. And we do that through being hard on the process and easy on the people. So let's have a look at another example. So when do you stop? Like, you can keep asking that question, why, sort of until the cows come home. But when do you stop? So here's a sort of an example about that. So problem statement in this case, well, the machine stopped operating. So we'd ask the first why. Why did the machine stop? Well, the fuse melted. Well, and that'd be quite often for organizations that don't have a formalized problem solving. They just go and replace the fuse, and then it would happen again and they'd replace the fuse again. What we want to get down to is stopping the problem from occurring. We can only do that if we know what the root cause is. So we'd then ask another why. Why did the fuse melt? Well, it overloaded. Why did it overload? There was inadequate bearing lubrication, and the machine drew too much power. We then ask why again. Why was the lubrication inadequate? Well, the oil pump was not drawing enough oil. Well, why was the oil pump not drawing enough oil? Well, the pump shaft was worn. Why was the pump shaft worn? The oil was contaminated. And then finally, why was the oil contaminated? There's no filter on the intake pump. Now, this sounds like there's another why involved, but when we know we've gotten down to the right place, where we've gotten down to the right why, is if the causes start to expand again after we ask why, we know we've gotten down to the root cause of the problem. The root cause of the problem in this particular instance is there's no filter on the intake pump. That's the problem we need to solve. If we continue to ask why at this point, there's no filter on the intake pump. Why is there no filter on the intake pump? The process starts to expand again. We start saying, well, maybe it's engineering, or maybe it's there's some other reason on the intake pump that there was no filter involved. Maybe it's designed to not have a filter, or maybe it was. You get what the idea is. The possible causes start to expand again. In this instance, the why, the place where we need to solve the problem, is on no filter on the intake pump. because otherwise our problem starts to expand again. So there is a place, and what we want to do is validate. So the other thing that we want to do here is we want to validate what our root cause is by using the so therefore process. So this is a process that we use if we think we've gotten down to the root cause of a problem. We use so therefore to validate that it actually prevents recurrence of the problem. So the first thing we want to do is confirm the facts. So if we were looking, let's suppose we've gone through our fishbone diagram process. We went through, we got ideas about why a problem might exist. We then prioritized those ideas and we went through the 5 why processes on those ideas. What we would want to do is confirm the facts then out at the Gemba. Here's the information that we gathered. What we need to do now is confirm those facts, and we would do that out at the Gemba. And we would continue to ask why when we've got the facts confirmed. And we would stop asking the further why when the fact is not a clear cause. So we go out there, we confirm the facts, and we keep asking why. And what we want to get to is we want to get to a place where if you block the cause of a problem, you eliminate the effect. So the best way to demonstrate the cause and effect relationship, and remember we talked about the fishbone diagram actually being called a cause-effect diagram in some circles, is to remove or block the cause. If the problem goes away, you know you've found one likely source of the problem. So that's where we want to get to. And we do that through using the so therefore verification. So we check if what we have identified is truly the root cause. And we do that by knowing if we ask why one more time, the cause would spread out, such as what we talked about with the intake of our oil filter. And then we come with that possible cause, and we use the so therefore process and work backwards to confirm that we're actually got the right root cause. So here's that idea illustrated. So we have in our last example that there was no intake filter for the oil in our machine. And we came down to and decided, because if we asked why one more time, the problem would spread out, we decided that this is the root cause of our problem. So our cause was there was no intake filter on the oil pump, and that caused the oil pump shaft to be worn, and that caused insufficient pumping of oil in our machinery, which caused our machinery to overload, which caused the fuse to melt, which caused the machine to stop. All of that makes logical sense. And so our so therefore verification would confirm that the possible cause that we're working with is the proper cause for us to say that we've got a solution for our problem. And we do that through working backwards in our so therefore process. Now let's look at another example of this process in action. And here's a simple problem here where we've got milk in the fridge and the milk has gone bad. It's gone sour. And so we'd start our 5 why process, and we'd say, why did our milk spoil? Well, it was left in the fridge for too long. Why was it left in the fridge for too long? We didn't drink it fast enough. Well, why didn't we drink the milk fast enough? Well, we had more milk cartons than we needed. Why did we have more milk cartons than we needed? Well, we bought more milk cartons than we needed the last time we went shopping. Why did you buy too many milk cartons? Well, there was a sale on milk and I wanted to save money. So we would check with the so therefore process to see if that was the root cause. So we'd start there. There was a sale on milk, and you tried to save money. So therefore, we bought more milk cartons than we needed the last time we went shopping. So therefore, we had more milk cartons than we needed. So therefore, we didn't drink it fast enough. So therefore, it was left in the fridge for too long. So therefore, it went bad. It all makes logical sense. And so we could conclude that we did get down to the root cause of the problem. There was a sale on milk and we tried to save money. Again, looking at that process, if we ask the question why one more time, what problem we're trying to solve is, why are we trying to save money rather than why did the milk go bad? So the cause would spread out if we continued to ask the 5 whys, or a why at that point. So that's the so therefore verification process. So how can we formalize all of this problem and communicate this problem solving process for our work groups or the offices that we're dealing with? Well, what we have is a 3C process for our, also called, sometimes referred to as an A3. An A3 being the size of the paper that you might be using to work this through. But our 3C process, and it's a little bit confusing in that in the 3C problem solving process, you actually have 4 C's. And the 4 C's consist of our case, our cause, our countermeasures, and checking. We see this often used with the goal of solving simple problems, and using this on things like huddle boards during your daily Kaizen meetings and things of this nature. So what does it look like? Simple 4-quadrant matrix. And where you start with a 3C tool is you start with the case. So here's a simple case that we might use the 3C process for this. The case that we've got is Chuck is getting married next summer, and he's been trying on the tuxedo he bought on sale, and the tuxedo no longer fits. Some of the data that we would collect for this case, well, Chuck's current weight is 220 pounds. His weight when he bought the tuxedo a year and a half ago was 196 pounds. He started cohabitating with his prospective bride a year ago, and he stopped playing hockey 2 years ago. Of course he plays hockey, he's from Canada. We then go along to do some problem solving. We've got the case, we come up with a problem solving statement. Chuck no longer fits into his tux, and we then come up with a cause and effect diagram to try to find some of the reasons for that to happen. So some of the causes, we've got up here 5 M's. We've got methods, manpower, materials, machine, and means. The problem statement being the weight gain that we talked about. And we come up with some of the possible causes for this problem. For instance, maybe he's eating too fast. Maybe he's sleep challenged, and we know that people who are sleep challenged tend to gain weight. Maybe he's got an inability to cook, can't cook for himself. Or maybe there's stress. Maybe it's the fiance's influence. Maybe she's cooking a lot of fatty food since she moved in. Or maybe he's consuming too much fast food. Maybe he doesn't have a dishwasher. Maybe this causes him to want to get a lot of fast food. And maybe there's too many fast food restaurants in the neighborhood. But this would be the next step, as we would come up with possible causes for the problem statement that we're trying to solve. And we then might prioritize those things as illustrated by the different colors here. This problem solving group prioritized the 3 problems in red as being the ones that they might use the 5 why process with to come up with root causes. We then go along to develop countermeasures. What we want to do, we identified stress here as being one of the possible causes of the weight gain. So we want to start a regular workout to burn calories and reduce stress levels. We define the inability to cook as a priority problem. We want to make a healthy cooking course together with the fiance. And we also talked about being sleep challenged. We didn't develop a countermeasure for that, but we did come up with defining the maximum amount of meals eaten outside of the household as a possible countermeasure to the problems as well. We would then go along to develop checks. How are we going to check to see if we're making progress around solving this problem? And so finally, we would have weekly weight monitoring and a record of all meals eaten outside of the household. So what we would want to do, make sure we do here in the check category, is to ensure that that we've got things that are specific, your regular SMART goals, where you've got checks that can be specific and measurable and attainable, and that we can actually keep track of all of these things that we come up as checks for the 3C process. So that's a very simple communication tool that we can use to illustrate the problem-solving processes that we use. So in summary, what we can use is our Ishikawa diagrams, our fishbone diagrams, and implement brainstorming to come up with possible reasons for a problem. We can then use our 5 whys process to funnel down to get down to root causes. Once we get to root causes, we can identify countermeasures and ways to check to make sure that we're avoiding the problem in the future, and then use the 3C process to communicate our problem-solving process to our organization. So that's our presentation on simple problem solving. With that, I want to thank our partners at Sioux College for participating in the creation of this process. Also want to remind everybody out there that we have upcoming webinars this week. We have one on DevOps that is coming up on Thursday. We've also got a series of webinars that we've captured on our YouTube channel. Following the webinar here, you will receive an email that contains a survey that if you respond to the survey, you'll get a certificate of attendance for the program. And also you'll get links to our YouTube channel and to a place where you can download the PDF of the slides that we talked about here today. So to everyone, everywhere, every day, stay well, never stop improving. We're going to continue on to a QA, and I'm going to turn this over to Jesse here right now, and we'll go through our QA process. Go ahead, Jesse. Do we have any questions?
Well, thanks so much, Chuck, and we really appreciate your time today. Just giving Chuck a minute to catch his breath there. If you look in the QA section, we did just post the link for the survey for this webinar, and you can click on that link and fill that out. It'll be open for about 24 hours, and again, this is how the certificate of attendance is generated. So please make sure that you do that if you would like to get that certificate. And we do have some questions, Chuck, and while you were teaching us about simple problem solving, we were also working on some simple problem solving here in the background and solved a link issue. So application in real time, everybody. It was like I was getting coached from Chuck. So the first question we have is, how do we prioritize the strongest cause based on what? So is there a tool or something that you're using to prioritize what to solve first?
You can use something that's we call a priority matrix in problem solving. Quite often, my experience has been with the simple problems is that it'll be intuitive as to which ones to go after first. But if we do go into a more complex problem solving situation, what you can do is you can develop a matrix where you can, on the vertical axis, you can put how difficult will it be to create or to implement the solution to this problem, from very, very difficult at the bottom to very easy at the top. And then along the horizontal axis, you can put what's the what's the effect going to be from very little effect to a great effect on the cause. And you can prioritize that by saying, well, this possible solution would be easy to implement, and it would also probably get us a long way towards solving the problem, and you'd put that in the top quadrant of the matrix. So you can use a priority matrix to solve problems. But what we find is in the actual fishbone diagram brainstorming impact, when we prioritize, you can ask people to simply put check marks about which ones we think we should try first in terms of prioritizing as well. That's the usual process that we follow in problems, simple problem solving.
Gotcha. And a little bit of a follow-up to that then, as you're looking at an Ishikawa, the fishbone diagram, and you're prioritizing, is there a way that you would also suggest validating the information that's on the Ishikawa, or making sure that we're eliminating bias out of the decision-making process?
Right. So what we take out our possible solutions, or prioritize possible solutions, and we vet those. We go out into the Gemba, and we get we validate the information that we were using when we talked about it. So that's your opportunity there to ensure that it's not just bias from perhaps the group that was involved in the brainstorming, but going out there and gathering data and ensuring that you're working on the right problem. What we need to remember is when we're in these problem-solving groups, we don't have all of the information. We are limited to the information that's contained with the people who are doing the problem solving. We need to go out into the Gemba, we need to gather facts, and before we implement the countermeasures, we need to ensure that we're dealing with the real information and that we're not subject to the biases that the person talked about.
Great. I really love this next question because, I think that's one that I've ran across as well too. So your recommendations about using and sticking to why. So in other words, not kind of as we're going through 5 whys, getting into what or whose, and is there a tool or any suggestions you have for framing up the problem to ensure that you're using a why statement to keep the flow?
So keeping it as simple as possible is perhaps your best tool around that. So coming up with the good sort of initial problem statement is important, and keeping that as simple as possible. So in our example, where we had the pump with the fuse melting and because of the inadequate or the missing oil filter. What we wanted to do is ensure that we kept the problem simple at each step along the way. So why did the pump stump? Well, the fuse melted. That's a very simple statement, the fuse melted. You can get very detailed into all of that, where, well, the pump, we were tracking the pump power and it peaked at such and it did. What you want to do is you want to keep it very simple, and that allows you to just simply ask the question why, and then team it up with why did the pump draw too much power? Team it up with the last statement, and that allows you to keep it simple and just simply keep asking that question why, because it is easy to get mired in the detail, but what you want to do is keep it simple every step of the way.
Really good. And we do have one more question, but just a quick reminder to everybody, the link for the survey for this webinar is there in the Q&A box. And I would also encourage everyone, if they are looking to follow up on this webinar, as well as get the slides, the email that comes out this afternoon with the link to the survey will also have a link to join our LinkedIn group. It is a invitation only group, but if you've attended a webinar, we let you right in and you have access to all of our past webinars, the recordings, as well as the slides. So a really great resource for everybody on the call. So look for that. And our last question for you, Chuck, would you say that on the 7th why that you start using a fishbone diagram?
Now, they're two independent processes, and usually if you've got a process that is complex enough to want to use a fishbone diagram at some point in time, you'd start with that, as opposed to go to that as you ask, use the 5Y process. I would use the 5Y process alone if I was dealing with a very simple problem. If I've got more complexity, I want to start with the fishbone diagram problem and then work my way down as I identify possible contributors to the problem to use the 5 Ys. Now, it could be at some point in time that you think you're dealing with something simple and you just automatically launch into the 5 Ys, and it becomes apparent that it's complex. And at that point in time, you might say, oh, wow, maybe we stop this 5Y process right now. Maybe we go to a cause and effect or a fishbone diagram instead. So it could happen. But the usual flow would be you'd recognize that a problem is got perhaps more than one contributing cause. You'd start with a fishbone diagram and then use 5 Ys on the individual causes. But it is possible at some point that you could realize it's not as simple as you thought and then go to the, if you're down to a 7th Y, you're probably dealing with something that's fairly complex. So yes.
Gotcha. And Chuck, we actually had 2 follow-up questions come in with that. So how would you best define the tool to be used for analysis? Any recommendations?
If I'm doing some deep analysis, I'm probably doing it with a team engaged in a cause and effect or fishbone diagram problem. That would be my analysis tool.
Yeah. Got it. Okay, and then the last one that we had come in there, can we use the sample problem solving problems, as part of our everyday life? Yes. Is that a good thing to do?
Absolutely. That 5 Ys process is dynamite. If particularly you work in a role where there's a lot of problems that crop up, that 5 Ys process, you can just pull it out and use it anytime you want to. But with the one sort of proviso that I'm gonna state again. Tell people that you're using the tool, explain the tool, educate. If you have a work group, educate the whole work group on the 5 Ys process, because that reduces the defensiveness that people automatically feel when somebody asks them the question why. So with that proviso, yeah, use it. It's a great thing. Pull it out of your pocket. Let's use the 5 Y process on this. So why did the state the problem happen, and then right. Go along. Yeah.
Right. Well, really great insight. And everyone, we thank you so much for joining us today for this webinar, and to our partners at Sioux College for being such gracious sponsors of this today. So thank you again. We hope to see you on another webinar soon. And again, the link for our survey there in your question and answer area. And we hope to see you again soon. Thanks, everyone.
Thank you.